in row 6 of your assignment sheet. We started investigation number 3 on Monday. What I had you do on Monday is work through the GeoGebra application to see if you could find special characteristics or properties about quadrilaterals. And that's what this is about. We're looking at congruence in quadrilaterals. What we're going to do is we're going to use our information that we've learned about congruent triangles and properties of parallel lines. And this is what we're studying right now. We're proving properties of special quadrilaterals, and that's our focus for today and what we've been working on. Our bell ringer today was what was the definition of a parallelogram. The definition of a parallelogram, we want to try to remember that as a very concise and succinct definition. It's a quadrilateral whose opposite sides are parallel. What is one characteristic or trait of a parallelogram that we'd already proven? That was we were able to prove that if it is a parallelogram, then the opposite sides must be congruent. So with that, we have two basic facts that we know about a parallelogram that we've proven and we've been given by definition: that the opposite sides must be parallel and that the opposite sides must be congruent. The next thing I had the class do is that we looked at naming each figure with the most descriptive name. So figure A is a trapezoid. Its distinctive features is that it has exactly one pair of sides that are parallel. So one pair of sides parallel and the other two sides are not. So that's a trapezoid. And part B, or question B, that is a parallelogram, and it fits our design and definition of a parallelogram. Both pairs of opposite sides are parallel. In letter C, this figure is a kite. A kite has a very distinctive shape, but its definition is a little bit harder to remember. The best definition I can give you for a kite is that it has two distinct adjacent sides that are congruent. So what I'm going to do is I'm going to put the cursor on this side. If I put my cursor on that point, these two sides are congruent to each other. They're two distinct adjacent sides. They're next to each other. The other place I can do that is over here. Those two shorter sides are two distinct adjacent sides that are congruent to each other. But it isn't necessarily true here at this vertex. So there's two pairs of adjacent sides that are congruent. In letter D, that is most commonly recognized as a square. And letter E, E is a rhombus. A rhombus is another type of parallelogram, just as a square is, but it has four congruent sides. In letter F, it's a rectangle, is the most descriptive name for it. It also fits into this category of a parallelogram. And letter G is just a quadrilateral. It doesn't have any special characteristics in which we design a name for. So it's just simply a quadrilateral. So the last question, which figures above would be appropriately classified as a parallelogram? Well, any of these figures where it has two pairs of opposite sides that are parallel, so that means B, D, E, and F are also parallelograms. So that was the first thing that we did to get ourselves started, and that's what we're focused on today. In this slide that I'm showing you, this is what we proved on Monday after we did our investigation. We proved that if it was by definition, a parallelogram and the opposite sides are parallel, it would have to have corresponding sides that are the same length. And then we went back through it the other way, that if we were given that the opposite sides were equal in length, then they would have to be parallel. So those two things kind of go hand in hand, and that's where I came up with this information that I had here that's going to be coming up. So, and I just will address that now. So far, here's what we know we have proven. We have proven that by definition of a parallelogram, that we have both pairs of opposite sides that are parallel, and then we have followed that up with a proven property of a parallelogram is that the opposite sides of the parallelogram are congruent. So that's what we've done so far, and I've also had you work on the GeoGebra program, and what you were supposed to do is you're supposed to get all the common features that you know about a parallelogram, rectangle, rhombus, square, and kite. So I gave you a list of questions, and then I had you answer these questions. If you have a parallelogram, were each of the diagonals, or did each of the diagonals divide the parallelogram into two congruent triangles? And then you went right down this list and you made some conjectures about whether you thought they were true or not. This is the one column that I didn't have you do before, but I added in there because I needed it for a rhombus and a square as well. So you went and you did that in class, and you followed the procedures and the routines, and hopefully what we were able to do, and you can check this, is you were able to check off these ideas that we conjectured from the investigation that we did with the GeoGebra. So what we're saying is anything that has an X in this box means that we believe that's going to be true anytime that you have a parallelogram. So we believe that the parallelogram has these four characteristics for certain that will always be true. So every time we have a parallelogram, what we can say is the diagonals will bisect each other. And every time we have a parallelogram, the consecutive angles will be supplementary, which means they add up to 180. And that's what the X's in this chart mean. So if you go down to the rectangle, since a rectangle is a parallelogram, it's going to have the same checks that a parallelogram does, but it has one additional one, and that is that the diagonals are congruent. So that was a special trait or characteristic of a rectangle. Also, a rhombus is always going to be identified as a parallelogram. It has the same characteristics. The opposite sides are parallel. So therefore, if you look at those, it has the same check marks as a parallelogram, but it has a couple of extra features as well, or properties, that their diagonals will be perpendicular and that their diagonals will bisect the vertex angle. And we'll get into that a little bit more. Finally, the last parallelogram that we have is a square. Now, a square is a rectangle, or a parallelogram. A square is a rectangle, and a square is a rhombus, which means square has all the features of these other three. So if you look, the square has every characteristic of a parallelogram that we had listed. Since a square really could be identified as a rectangle, that means that characteristic is the same. And since a square is a rhombus, it has the characteristics that a rhombus has, where the diagonals have to be perpendicular to each other, and that they also have to bisect the vertex angle. So that's kind of what we were supposed to be doing. You guys didn't have that worksheet before you left if you're watching this down at state basketball, but we were asked to answer the questions yes or no. Then all I had them do in class today is organize them in this type of a worksheet. Because what I want you to be able to see is every time you have a parallelogram, you have 4 features that are inherent in that. And a rectangle, rhombus, and a square are all parallelograms. And a square is a rectangle, so therefore it's going to have every characteristic of a rectangle, which means it's going to have all the 4 characteristics of the parallelogram, but add into your diagonals are congruent. So that's how that's supposed to work and how it's supposed to look. Okay, and then the next activity, what I had them do is I said, all right, complete this chart. And I guess I already scrolled down on that, so I was going to walk you through it, but we're supposed to fill in this quadrilateral tree, which is supposed to help us identify what characteristics trickle down to the next one. So in this diagram, the quadrilateral is the big category of how we classify 4-sided figures. Once we get into 4-sided figures, now we start breaking them down into 2 other classifications. A kite, which basically has no 2 sides that are parallel to each other. So we have a figure that has no sides parallel. Then we have a trapezoid, and a trapezoid by definition has exactly 1 pair of sides parallel. So we go to 4-sided figures, we start classifying. They don't have any sides that are parallel, but we have 1 side that are parallel. Then underneath the trapezoid, I'm going to go there first, is a parallelogram. Now, a parallelogram could be considered a special type of trapezoid because it not only has 1 pair of sides that are parallel, but it has 2. So if I'm on a parallelogram, it automatically has all the features of a trapezoid, which means it has 1 pair of sides parallel. Yes, absolutely. It actually has 2. So once you're in a parallelogram, then you can look at what it can be branched off into. What's more specific than a parallelogram? Well, a parallelogram could be a rectangle if it has 4 right angles. So that means every rectangle is a parallelogram. But more importantly, any feature that a parallelogram has, a rectangle has as well. So that means, from our definition, the opposite sides are parallel, and also that the opposite sides are congruent, another proven identity that we talked about. And then if I keep following the trickle-down effect of this, a square is always going to be a rectangle, and it's always going to be a parallelogram. And it will always have the characteristics of a trapezoid. So basically a square is going to have at least 1 pair of sides that are parallel, and it actually has 2 pairs of sides that are parallel, like a parallelogram, and it has 4 right angles like a rectangle. And it has, as we saw in our chart above, the diagonals that are congruent. So I'm trying to explain how this diagram works, and what we're seeing is that every characteristic of the one above it trickles down to the one below it. So if a rhombus is below a parallelogram, then I can be assured that its opposite sides are parallel, its opposite sides are congruent, and every feature about a parallelogram is then true about the rhombus, such as the diagonals bisect each other, the opposite angles are congruent, the adjacent angles are supplementary, and what's new and special about a rhombus that makes it more distinguished over a parallelogram is that it has 4 sides that are congruent. A lot of times they will give you a definition that says adjacent sides are congruent. And it's just another special type of parallelogram. And then the square is a special type of a rhombus that has 4 right angles. So a square has 4 congruent sides, just like a rhombus. It has every single feature of a rhombus plus an additional one where it has 4 right angles. So that's kind of how this thing is built or set up. So a quadrilateral has four sides, so does a kite, but a kite is a little bit more specific than a four-sided figure. It has two distinctive adjacent sides that are congruent to each other. Well, that's kind of like a rhombus, because a rhombus will have the adjacent sides will be congruent to each other, not just two distinct, but it has not just two, it has all adjacent sides that are congruent. So that's kind of how it's set up and how it's built, and then we're going to take a look at some of these special properties that are in this that are trickling down. So I'm going to pause this for a second and turn off that big fan. It's going to get loud, so I'll be right back. Okay, here's where the value of this quadrilateral tree, if you understand how it works, really comes in and plays big dividends later on. Because if you have a quadrilateral, you know it's a four-sided figure, so then that means if we look at the specific kinds, there are two kinds. Those that have no sides that are parallel, like a kite, and those that have exactly one pair of sides, like a trapezoid. Well, every property of a trapezoid trickles down into a parallelogram, which means if it has one pair of sides parallel, then a parallelogram has exactly, or at least one pair of sides parallel, and has two. Where we're going to spend most of our time is sitting right in here in this part of this diagram, because we're going to be focused on parallelograms. So what we have is some definitions and some properties of parallelograms that trickle down into all the others. So here's what we have for properties if the quadrilateral is a parallelogram. We have 5 distinct properties that we need to know and we're going to have to prove are correct in this parallelogram. And we've already proven that the opposite sides are congruent, so that one's done. But these are the 5 things that we found in our investigation using GeoGebra about what we thought would be true. Well, these things are true, which means all 5 of these trickle down into a rectangle, and all 5 of those trickle down into a square, and all 5 of them trickle down into a rhombus. So if you ever have a rhombus and you're working with a rhombus, you know that the opposite sides are congruent. You will know that the opposite angles are congruent. You will know that diagonals will bisect each other. You will know that they have consecutive angles that are supplementary, and you will know for sure that the diagonals will divide into 2 congruent triangles. The stuff that I put off to the side here is the extra stuff. Not only do you have everything that a parallelogram has, but you also have some unique characteristics only to a rhombus. And that's what these are. That says the diagonals are perpendicular, and they will also bisect the vertex angles. So a square, since it's in the bottom of this tree, has every single characteristic of a quadrilateral above it. So what we know about a square is it has these 5 characteristics. We also know that its diagonals are congruent. We also know that its diagonals are perpendicular, and they bisect the vertex angles. So if you understand how this table is built, or this diagram is built, it's very, very useful, and it helps you remember all the characteristics that belong to a certain parallelogram, or quadrilateral for that matter. So I'm going to stop with this part of the video, and the rest of it's going to be doing some proofs and derivations of why each of these are true. So that's just kind of getting our feet wet and fundamentally where we're headed.